Hi, my name is Alyosha, and in this video I present our demo on showcasing data management challenges for future IoT applications. An ever-increasing number of sensors allows for novel IoT applications in domains such as healthcare and the energy industry. Recently proposed data management systems such as IoT DB and NebulaStream enable such applications by going beyond central data processing in the cloud and additionally utilizing processing nodes in the fog. This allows to reduce data transfer to the cloud and thereby to decrease overall data processing latency and costs. However, processing data in unified fog cloud environments comes with several key challenges, three of which are ingesting data from heterogeneous and disaggregated data sources, operating in complex hierarchies of processing nodes, and performing actuation of physical environments in real time using sensor data. To enable visitors of our demonstration to experience these challenges and how to address them, we introduce IoTropolis. To showcase the free fog cloud environment challenges, IoTropolis realizes an eHealth scenario that is represented via hospitals, where patients enter, where they are treated, and where they leave again. Furthermore, IoTropolis realizes a smart grid scenario via solar panels that generate electricity during the day, where electric vehicles that run on battery power and that need to recharge when they run low. Additionally, there are factories that continuously consume electricity. Also, there are households scattered throughout the city and street lights. Finally, there are also wind turbines. During our demo, you can manipulate data generation via the control menu on the top right. For example, reducing the wind speed decreases the amount of electricity produced by wind turbines. This is directly reflected visually and impacts all processes depending on electricity generated by wind turbines. You can also control traffic density, patient load on hospitals, and the time of the day directly. The actual data generation for different sources is executed separately using Docker containers. As a result, you can scale data generation independent of the performance of the visual component of IoTropolis. Moreover, you can configure sources concerning data formats and messaging protocols, which is challenge 1. In the following, we will show you how you can work with the data generated by IoTropolis, for example, to automatically control the number of active streetlights at night, which is challenge 3. Using our recently proposed data management system for the IoT NebulaStream. During our demo, you can interact with NebulaStream via our UI. For example, you can investigate the topology, which gives you an overview of all the processing nodes that NebulaStream operates on. You can also click on individual nodes to look at their specific metrics. Furthermore, you can click on the query catalog to create or submit queries, or to look at details for already submitted queries, for example the query plan, or to see how individual query operators are placed in the processing node hierarchy for execution, which is challenge 2. Of course, you can also visualize query results based on the data generated by IoTropolis. Simply choose a query ID, the type of graph that you want to use, and edit. We can see that overall more electricity is generated by wind turbines, which is shown on the top, than by solar panels, which is shown on the bottom. We can also see that solar panels do not generate electricity during the night, which is to be expected. In another query, we can visualize the overall produced electricity on the left and the overall consumed electricity on the right. If we now decrease the wind speed, which affects wind turbines and thereby the overall produced electricity significantly, we see that the relationship changes. This is one of the ways in which you can manipulate data generation during our demo. At night, consumed electricity might outgrow produced electricity. You can counteract this via actuation queries that allow you to control the number of active streetlights at night. This is challenge 3. In the future, we want to add technical details such as speeding up time. We are working on making existing scenarios more interesting, such as the eHealth scenario, adding events to the city that affect scenarios, adding new scenarios such as a public transport scenario, and we would also like to add benchmarking capabilities to the city. That's it from our side. We hope you're excited for this demonstration. Thank you for listening.